How are you, everybody who is watching this video? My name is Olenjolai TAYAI from beautiful, fantastic country called United Republic of Tanzania, and this is our national flag. I would like to welcome you onto our online school that called Tanzania Ordinary Secondary School in square bracket Olenjolai. And then I would like to also take this short moment to welcome you onto our one official YouTube channel that's called Tanzania Online O-Level Safety School. So we welcome you into Tanzania Online Ordinary Secondary Schools in square bracket Olenjolai. We welcome you into our YouTube channel that's called Tanzania Online O-Level Safety School in square bracket Olenjolai. A vision we have in this fantastic online schools, okay? We would like to be a part of trainers or teachers who would like to prepare a special group of Tanzanians, even Africans or in other continents or in other countries, who would like to take the classroom instructions in mathematics, in basic mathematics plus basic science, meaning that in physics, chemistry plus biology, and even agriculture science in some of the aspects, to combine the spiritual knowledge in order to solve real life problems. So our main objective in this platform or in this program, we want to see our students when they are studying or after they graduate, they are solving critical real life problem or problems in plural. So for instance, myself, who is teaching you right now, I'm solving a problem. What problem am I solving? Yes, it's a challenge for every student who have passion and vision in basic mathematics and science subjects to understand all the concepts for the 4 years which have been dedicated for ordinary secondary education. Right? So that the vision that we have, and we are solving a national problem. And I would like just to say that these contents that we are going to cover in these online platforms might be useful in any continents, in any country, in any ordinary secondary school, and even in some of the ordinary diploma institutions. They can use this material as the fundamental materials. However, that our main focus will be paying attention on the syllabus, or will be focusing on the syllabus of United Republic of Tanzania. So again, we have 3 departments. We have departments of basic mathematics, where we teach students 4 subjects: basic mathematics from 1, basic mathematics from 2, basic mathematics from 3, and basic mathematics from 4. So today we will be teaching you a subject called basic mathematics, and this contents is for the Form 4 students or class 12 in some of the countries. So before we start our sessions, I would like just to remind you some of the reference books that I've mentioned in the general in session 00, that is to be written general introduction. Okay, so general introductions of 40 general introductions of basic mathematics in Form 4. So one of the reference books that I have recommended is this one, which is called in Basic Mathematics Syllabus for Ordinary Secondary Education, Form 1 to Form 4, and this has been written by Tanzania Institute of Education. Again, that the students, when you'll be taking this material, you should have in your hands one of the book that called Secondary Basic Mathematics Book 4, Tanzania Institute of Education. In case that you are lacking this book, you can read descriptions of this video and you'll see how much does it cost you, and we can ship this book in any regions of United Republic of Tanzania. Similarly, in case that you want a book or a photocopy of this book, you can order online and we can ship it in any regions of United Republic of Tanzania. Again, I have another textbook, reference textbook, that's called the Mathematics for Secondary Schools, Form 4 students books, and then it has been published by the Oxford. Very useful for the Form 4 educations. Again, I have question and answer reference book that called the Ordinary Level Mathematics Review, Problems and Solutions from 2003 to 2019. So you should have them in your hands. Like myself as a teacher, I prepared my session, or I prepared my periods or my contents by using more than this reference material. Remember that another reference material that you can use, online materials, online books and materials are very useful for you to learn basic mathematics and even some other concepts of mathematics. Well, so again, we insist you to remember to subscribe into our YouTube channels, and we insist you to read the description so they can get further instructions concerning about these channels and even some other official YouTube channels that we have. So let us go into the today's sessions, okay? Into the today's session. Today, this is the first topic for the Form 4, as well that we have 8 topics in Form 4. We have 8 topics. Coordinate, let me remind you, coordinate geometry. That's the first topic. The second one is area and volume. Third one is three-dimensional figures. The fourth one is probability. The fifth one is trigonometry. And the sixth one is vectors. The seventh one is matrices and transformation. And the last topic that I'm going to teach you is called linear programming. And we are going to solve linear problems as well as we can. So this is session 2. It's not just session 1. We are done with session 1. In case that you missed this session 1, so you can go and you can write these channel names, or all-level channel names that called TANZANIA Online All-Level Secondary School, in square bracket Olenjolai, in the YouTube search engine. Then you see the channels. Then you have to watch the video in the detailed session 02, General Introductions of Coordinate Geometry. So you have to make sure that you do that. So today we are in session 2, that's titled Gradient of the Straight Line. Again, remember that this material I'm going to solve you, they will not end its usefulness in ordinary secondary education stuff. When you graduate successfully and you pass ordinary education or ordinary level, then you have 2 routes. You might take the right side hand you may take this route to go to advanced education, where that actually more than 70% or in our country that they pursue advanced education. You may also take a route of ordinary diploma. Yes, ordinary diploma in engineering and scientific courses. You may encounter mathematics and coordinate geometry will come into play, because the one of the recommended topic for the rest of your life. So let me do the quick review. So the quick review of the previous lecture, I want to link the previous lecture, our previous session, okay, and today's session. That was session 1. So what did we cover? First of all, I introduced it to you Vision of 40 of Tanzania Online O-Level or Ordinary Secondary School, and the founder is Olenjolai. That's the first thing. Secondly, I told you about the problem, okay, problem statement that I'm solving in this platform. So I'll be trying to solve. Again, I presented to you the big picture, right? The big picture. This is the session 00, right? I present to you the big picture of basic mathematics. Again, I mentioned reference books, and I categorize them into 2 groups. We have textbooks, and also we have question and answers books, right? And then finally, I introduced the topics, the 8 topics, okay, the 8 topics of 40 of basic mathematics from 4, right? Then the quick review in session 1 of coordinate geometry, right? Of course, this also still in the YouTube channel, so you can watch and you understand the whole picture of basic mathematics for the Form 4. In session 1, the general introductions of coordinate geometry. Basically, first of all, I introduced to you about subtopics, right? Subtopics. We have 3 subtopics, 4 subtopics, okay? So subtopics of 40 of coordinate geometry. So 4 subtopics of coordinate geometry, right? And then at the the first system. Then I shared to, or I presented to you specific objectives. So specific objectives of 40. Specific objective of each subtopic, right? Of each subtopic. Then I began to introduce, to teach you about the general introductions, what the means of coordinate, right? What the means of coordinates, what the means of geometry, and what the meanings of coordinate geometry are the terms. Then finally, I ended my session on teaching you applications of 40, applications of coordinate geometry. So that's what the end. So today, I want to teach you about a concept called gradients of the straight line. So stay connected. So the fundamental question that we should have in our mind is, what is gradient? Okay? So this is the first question for this lecture, right? Question 1. What is, or define, what is the meaning, right? What is the meaning of 40 of the term gradient, or in sometimes we call it slope. What does it mean? Okay, it makes. So simply we have this definition, say that the gradient or slope, right? Gradients or slope of the line or curve, so it means that line or curve is a steepness. So is a measure of the steepness. This is the measure of the steepness of the line or curve. There's a difference between a line and a curve. Okay, however, that a curve might be also a line. So that's the definitions of the slope. So slope is the measure of the steepness of the line or the curve. Okay? Line or the curve. So that's the first definition, or a slope of the line, or some of the references, we define that slope of the line or curve. Okay? So you say that the change, so slope also is a ratio, slope is the ratio of the change. So slope is the ratio of the change in vertical, of the vertical change, of the change of vertical quantity to the horizontal change, to the change, okay, of the change of vertical quantity of, okay, vertical. So simply let us define this one. So I say that the slope of the line or curve is a ratio of the vertical change. It's a ratio of the vertical change. It's a ratio of the vertical change to the horizontal. To the horizontal change. To the horizontal change. Okay, to the horizontal change. That's the meaning of what? Of gradients or slope. And this is the second definition, is the one that giving us mathematical definition. So we say that it is the ratio of the vertical change to the horizontal change. So now we can say from this definition, mathematically, how do we define? Mathematically, slope is equal to ratio, as you say, change in vertical quantity, right, over change in horizontal quantity. In horizontal quantity. So this is the meaning of the word slope. Okay? So slope is equal to the change in vertical quantity or vertical axis to the change in what? In horizontal axis. That's how we define slope. So in geometry or in coordinate geometry, right? In geometry, so slope, we can define that this is the ratio of the change in y-axis over change in x-axis. Okay, change in x-axis, right? So before you even have a straight line. Okay, so this again is a a simple mathematical formula of the slope. So, what do you say? So you say that the slope or gradient of the line, right, is donatedly emits as what? Small or lowercase m. So for that reason, gradients of the straight line will be equal to the change in y-axis over change in x-axis. So this is another formula of gradient or slope. Wow. So in the case now, we like to clarify further and further that formula. So we say that consider figure 1a below. Okay, figure 1a below. So suppose that we have an xy plane. Yes, you have two coordinates there, which is ordinate. Remember that in session 1, I taught you about two vocabulary. The first one, I taught you about the horizontal axis in geometry according to Euclidean, right? Euclidean, that's the name of the mathematician. We call them, so it means that horizontal axis, we call it abscissa, and the vertical axis, we call it ordinate. So this is y-axis, okay, this is x-axis. So this is 0, 0, okay. So then suppose that we have a certain straight line here, okay, we have a certain straight line, because we are learning gradients of the straight line, not of any line, but of the straight line. And then suppose that we have 2 points. This is point P, we have this is x2, y2. And then we have a second point, which this one we call TQ. This will be x1, y1. You are allowed to call this x2, y2, x1, y1. So you're allowed. So then we have the x-axis and we have the values and the coordinates. So now we can formulate a right angle triangle. So we can formulate a right angle triangle. So this is the right angle triangle with dotted line, right? So right angle triangle formed between point P and point Q, right? And then here we have a symbol for the right angle triangle. So, what do you say? So we say that if, for instance, that we know, or we call this another point, because it's the right angle triangle right now, then we say that if this is the case, then we say that here we have change in y. And also here we have change in x. Change in y over change in x. So, for that case, we say that slope or gradient. Slope or gradient. This is equal to what? As we say, change in y over change in x. And this one, for this case, change in y, we can say that is y2 minus y1. Over what? Over x2 minus x1. Also, slope, which is gradient, is equal to change in y over change in x. Then we take coordinates of point Q minus coordinates of point P. That this will be y1 minus y2 over what? Over x1 minus x2. So all of these formulas are relevant formulas for what? For this concept. So gradient or slope of the straight line of any straight lines, if you do remember that, we taught you these concepts also during your Form 1 studies. So this is not a redundancy, it's just to build the strong foundations, because many students, they get discouraged with their performance or with the way that with their life or practical life in basic mathematics. So you say that slope, for that case, according to the figure, so this is figure, as I said, this is figure 1a. Okay, figure 1a. Change in y over change in x. This is equal to y2 minus y1 of what? x2 minus x1. And this is equal to y1 minus y2 of what? x1 minus x2. So this is the formula. So this is the formula that we employ in finding slope of the straight line. So slope of the straight line. Okay, slope of the straight line. Okay, so that is about the slope of the straight lines. We have discussed about its notation. Okay, so now if you know the formula, let me give you some examples. Okay, so example 1. These are very simple examples. Even a former student, after covering the topic of coordinate geometry, he or she might solve this problem. Find the, so remember, I'm building the strong foundations of coordinate geometry in the mind of the student. Find the slope of the line. Find the slope of the line joining the earplanes. In case that you find that I'm moving or I'm teaching you in very high speed according to your level or according to your speed of learning, you can repeat to watch this video several times as well as you can. That's the beauty of learning on digital platform. So 5, -2. Okay, so and then this one, the reference, refer basic mathematics books from 4, right? From 4, chapter 1. So chapter 1. So you see this question. So the question asks us to find the slope of the line joining the points A, which is 4,8, and point B, 5, -2. You can sketch a line, or you can just find, or you can just recall the formula, and then you just lay it. So let me do by using the simplest approach. Okay. So the first step, you say that recall the formula, right? Recall the formula of finding what? Of finding slope or gradient. So what the formula? Still have above. Gradient or slope of the line is the ratio of change in y over change in x. And this also is equal to y2 minus y1 over x2 minus x1. This also is equal to y1 minus y2. Don't get confused. You may use either. It's not that it's compulsory for you to use only this formula. You may use either this formula or this formula. So let us just to simplify the concept. Let me use the formula which you are familiar with. y2 minus y1. So this is x2 minus x1. So this is the formula that we are going to use. But remember that you'll be given 2 points A and B. You are free to choose point A to be x1, y1. And you can also, another students might say that point A, x8, this will be x2 and y2. So you may use either x1, x2, no, x1, y1, x2, y2, or vice versa. x2, y2, x1, y1. So you are free to to use either of those alternatives. Okay. So then the next step, we know the formula. We chose one, which is Y2 minus that one's. So we go for the second step. Okay. The students who have best mathematics might let point A, okay, to be x1, y1. So if that the case, it will be equal to x1 is 4, x2 is 8. So for that case, we say that x1 is equal to 4 and the y1 is equal to 8. Wow. Again, we have to let point B. What are the coordinates of point B? These are what we call them coordinates, 5, -2. So you can let this one to be equal to x2, y2. So no need for you to worry, because some of the students they will say that this should be y1. No, you are cramming. So if that's the case, you say that x2 is equal to 5 and y2 is equal to -2. Either the choice will give you the same value of the gradient. So then now we have our value. So we go for the steady state. The steady state, now we have to compute, or we have to find the gradient. So as we say that the gradient is equal to y2 minus y1, okay, x2 minus x1. Given, every givens. Y2 which is what? Y2 which is -2. What is y1? Y1 is what? It's 8. Then you have x2. What's x2? x2, it is 5. 5. Then minus what? x1, which is what? 4. So then you say that gradient is equal to -2 minus -8. This is -10. And then 5 minus 4. This is 1. So if you divide, you get -10. You go back to the question. Find the slope of the line joining the points A and B. So therefore, we say that the slope of the line. So the slope of the line is -10. That's the response. Even if, as I said, that you take y1 minus y2, x1 minus x2, so it will be 8 minus -2, which would be 10, and 4 minus 5, which should be -1. So 10 over -1 is equal to -10. So you still have the same response. Okay? So that is the first question. I would like to give you the second question. Okay? Second question. Or I would like to solve the second exam. This program is for the serious students and unserious students who are ready to be transformed to become serious. Okay? So then here is example 2. So example 2, the question said that, also this example 2, I took it in, refer basic mathematics, so refer basic mathematics books, book 4, exercise means that the students has to do exercise 1.1. Then question what? Question 1D. 1D or 1E? 1E. And find this one in page 10. In page 10. So let us read the question. Find the gradient of the lines joining each of the following pair. each of the following pairs. Each of the following pairs of points. So the question asks us to find fragments of the lines joining each of the following pairs of the points. Roman D for that question. So this is D and E. So it is -1, -4, and 4, 4, -7. Then on the E, corners have been given a half, 2, and 3, 3 of 1, 3. Okay, so read the question clearly and then we are going to kick it now. Do you enjoy the beauty of mathematics? Tell me in the comment section, please. Okay. Let's read the question. Find the gradient of the lines joining each of the following pairs of points. What does the word pair mean? 2, right? So joining what is the 2 pairs of the points. So this and this, the 1 pair, and this are the another pair. Okay? So, I believe that up to now we can pause the video. So these are just prints, so you just recall the formula and then let which is x1 or 1 and which is x2 or 2. For this one, A, at least it is containing fractions. Let me do on your behalf. Let me help you. Okay? So then we say that usually, the first step, call the formula and know its demands. So we call the formula of finding gradient of the straight line. So we say that the gradient of the straight line is equal to change in y or change in x. Change in y, we might use this form. So let us use this today. Okay, so that's the formula that we are going to use today. Then we say that the second step, we do like what we did there. We have to let. And today that the process of letting we have distinguished from that we have. in a few minutes ago. So he said that we have let a half, comma 2 to leave x1 So it is the case, he said that x1 is equal to half. Then y1 is equal to 2. Again, we said that have let another point. So we can let it to be equal to equal to x2, comma y2. So if you do compare, x2 is equal to 3, and y2 is equal to 1. Okay? 1. So then we go for the third step. Let us compute. Let's compute slope of 40 of the straight line. Okay? So I say that slope, right, is equal to what? As you say, change in y. So changing y for changing x. So for this case that you say today, take 1 minus y2 of x1 minus x2. What's y1? y1 is 2. y1 is 2. What's y2? y2 is 1 thing. Then again we say that what is x1? It's half. It's a half. What's x2? It's 3. So this is x1. x1 is a half. This one, x2 it is 1 thing. No, it is 3. So slope we say that 2 minus 1 thing. Two minus 1 third is equal to 2 thirds. That's for numerator. For denominator, we're going to have so 2 thirds, so a half minus 3. So it is 530, a half minus 3. So you have 0.5 minus 1 . So this is not a right response. So just you can do this computation, okay? So let us do together, simple. Slope or gradients, because if I'm using a machine, you'll be afraid that now this is the concept. So write every term in terms of what? Every term in fraction. And then there we have what? We have a half minus 3 3 over 1. Okay. So what are we computing? If you join me right now, you're only welcome. We are learning the concepts of gradient. We call it geometry at the first topic for the Form 4. So then we have, we are solving example 2, which is here in bracket we have 2 over 1 minus 130. I'm just copying what I have there. Then we have a half minus 3 over 1. So find the LCM of denominator. It is 3. Then 3 over 1 is 3 times 2, it is 6 minus 1. Here it is. Find the LCM there. It is 2. So 2 over 2, 1. 2 over 1, 2. And 3, 6. So 6 is, so numerator 6 minus 1 is 5. Then 1 minus 6 is negative 5. Okay? So if this is the case, you find that this is equivalent to say 5 over 3 divided by negative 5 over 2. So 5 over 3 now if you multiply fractions, then the position of numerator and denominator changes. So here it will be negative 2 over 5. So 5 and 5 cancel. So the slope is equal to negative 2 to 7. So slope, or gradients of the line is 12. Is 12. Slope of the straight lines is 12. So 12 now, it's not 12. So the line is negative 210. So you see, even fractions as coordinates, you can deal. That's the beauty of mathematics. So the slope of gradient is negative 2 over 3. So I have example 3 again. Okay. So let us go to example. Example 3. Okay, example 3, we say that also this refer textbook. Refer basic mathematics book. Basic mathematics book. Okay. This question has been stated there before. Now TAYI. Okay. So the question says that given. Okay, so now let us go to example 3. Let me continue to write. The reference is Basic Mathematics Book 4 by Tanzania Institute of Education. That's the reference that when you get this question. So given figure 1 below, so given figure 121 below, so let me sketch it. Just these coordinates, very interesting coordinates. So then for the lovers, this is special for the lovers of basic mathematics. Remember that I would like to remind you that keep this material for the rest of your life, whether you will take a route of diploma or you take a route of advanced secondary education. So you need this material. So I was not told, however, that I thank God, He insisted me to understand this stuff. But frankly speaking, nobody who had told me that if I will need these fundamental concepts in my future studies. That's why that I'll be telling you and reminding you several times. When you finish your Form 4 education, or your Class 12 education, don't throw away your materials. You will use them in any route. You might even use them when you'll be studying your bachelor degree or your bachelor studies or your undergraduate studies. So you have x-axis and y-axis. So this is just like a plot. So this is 1 unit, 2 unit, 3 unit, and then here we have -1 unit, -2 unit, -3 units, -4. Again here, suppose that you have 1. For you, because you have a ruler, you can draw a good XY plane. So this is -1, this is -2, this is -3, this is -4. Okay? So this straight lines is passing through 1, 3 and -3, 4. So 1, so x coordinate is, so the x coordinate is this. Okay, so this is the x coordinate. Okay, and then -3, -2. So you'll be given this XY plane. So don't waste much of your time thinking, how did they know? No, this is a code, it has been given. Okay, so this is the straight line. And these coordinates have been mentioned as -3, -2. And this coordinate here, it has been mentioned as 1, 3. Okay? So that's the figure. Calculate the gradients of the line in figure 2, 4. So the question asks you that calculate the gradient of the line in figure 1, So this is what we call to figure 1, Good. This is very simple. This is very simple question. Okay? It's it's a very simple question. Why is very simple? So look the way that you are going to solve. It's very simple question. Solution. So solution, the first step always, you have to recall, okay, the general formula. So recall the general formula of slope, finding slope or gradient. We say that the slope is equal to change in y over change in x. So while y, the familiar formula is y2 minus y1, and hence here in denominator we have x2 minus x1. So what is y2? So you have to let, right? So you can let this is x1, let this is x2, y2. So y2 for this case is 3 minus y1, which is -2, right? Because you understand how you can let now. And then x2, it's 1. And x1, it's -3. So you put them in brackets. So you say that slope is equal to 3. Then you have negative, since negative, this make plus. So it is 3 plus 2. Negative, we get plus, positive. So it's 1 plus 3. So then what do we get? 3 plus 2, which is 5. And then say 1 plus 3 is equal to 4. Right? So therefore we say that this is the slope, right? So we say that the gradient of the line in figure 1, is what? 5/4. 5/4. Okay? Good. Then I would like now to end this lecture or this session 2 of coordinate geometry for the Form 4 with the last concept that we call in mathematics collinear points, right? Collinear points, then I will leave the homework for you, and then so you enjoy. Or gradients of the straight line of more than 2 points, right? So we have a terminology, a very interesting terminology for the lovers of mathematics. And this terminology is called the collinear point. Okay? Collinear point. Say with me, collinear points. Or I want to teach you how you can find gradients of the straight line when you're given more than 2 points, right? So more than 2 points. So gradients. So in bracket, you can say that this, I'm teaching you gradient, right, of the straight line, okay, of the straight line, right, are the ones of the way of to prove of the straight line, okay, passing more than 2 points, okay. So that's the meanings of collinear points. So the fundamental question, which is common for Sir Olenjolai when he began to teach a new concept his student, okay? Then I always ask myself, what does that term mean? What the meanings of what of collinear? So what is the meaning? So define or what the meaning of collinear point? Because you know that sometimes we can be spending much time teaching you how you can find collinear, or how you can verify that the points or the straight lines are collinear points or not, or why you don't know what the meanings of collinear point. Collinear point. So this is a collinear point, right? So what is collinear points? Okay, so I found very interesting, or define collinear points, right? Very interesting definition. In maths, we say that collinear points are the points. So collinear points are the points. So these are the points. Okay, are the points lie on the same. Are the points that lie, not lie for the liar. No. Lie means that sleep. Lie on the same straight line. Lie on the same straight line. Okay? Or in a single line. Or in a single line. That's the means of collinear points. So collinear points are the points. So these are the points, first of all, that lie on the same straight line. Not two different lines, but same straight line. Or in a single line. So we find them in a single line. So he said that according to, I want to give you another point to strengthen that definition. So according to the Euclidean, this is the mathematician, names of mathematician, Euclidean, according to Euclidean, right? According to Euclidean geometry. Okay, according to Euclidean geometry, a set of points, okay, a set of points are considered to be collinear. To be collinear if they all lie in the same line. The same line, okay? Same line, irrespective of whether they are far apart, or they are close each point. Okay, so we have a comma there, irrespective. Irrespective whether they are far, whether this point they are far, apart, or close, they're far apart, or close together, to form a ray or a line segment. To form a ray or a line segment. So this is according to Euclidean. Let me explain what does it mean. We say that collinear points are the points that lie on the same straight line. So you have a straight line, we can have more than 2 points. You can have 3 points, 4 points, 5 points, 6 points, 7 points, 8 points, lines along the straight line, not along the curve, okay, or in a single line. So according to Euclideans, this is the father of geometry. According to Euclideans geometry, we say that a set of points are considered to be collinear if they all lie. So all they should be lie in the same line, or irrespective whether they are far apart or close together to form a ray or a line. What does it mean? Before I give you an example, let me present this concept in this second concept in the straight line. Suppose that you'll be given this is a straight line, right? And I'll be teaching you that the general equations. Okay, so I'll be teaching you how about this equation. But suppose that it's a straight line. So you can have this point A and point B, they are close together. You can have also another point C along the same straight line. And also you can have another point D. So it means that for this case, we say that points A, B, C, and D are collinear. So these are collinearity points because they all lies on the same straight line. A and B are closer, B and C they are apart, C and D they are farthest apart. That's the meanings of the concepts of Euclideans and the conditions for the points to be collinear. They should be all on the same line. Again, in addition to that, this you have to note. So you say that the collinear points, or let's say that, let me just write this one. Let me write it this way to be simple for you. Conditions for the points to be collinear, right? For the points to be collinear. The first condition is this: all the points, whether there are 3 or 4, all the points should be or must be, should lie on the same line, on the same straight line. That's the first condition. Second condition is say that gradient, the slope of any pair of collinear points is always the same. Is always the same. Very important phrase. Is always the same. So for instance, the gradient of AB is always equal to the gradient of BC, and this is equal to the gradients of AD, and this is equal to the gradients of BD, etc. And even this is equal to the gradients of CD, right? So that's the meaning of the second point. So if that's the case now, let me we say that okay. So this is figure what? So now this is figure 1C. Okay. So in this figure 1C, we say that, for instance, the slope of AB, for this case, should be equal with the slope. So, for example, in figure 1C, okay, the slope of AC, this should be equal to the slope of AD. This should be equal to the slope of BC. This should be equal to the slope of CD. This should be equal, slope of CD should be equal to the slope of BD. And this should be equal to the slope of AC is done. So how many are they? 1, 2, 3, 4, 5, 6. So this is the condition for the collinear points. Okay. So now I have an example, then I'll give you a homework for you so that you may enjoy the beauty of basic mathematics. So I have example 4. Example 4, then I'll give you the homework that you can solve it. Example 4 state that calculate the gradients. So plural, gradients. So this is plural, right? Gradients of PQ. PQ, gradients of the line segment PQ and QR. Then compare. Okay, compare by using points. On figure 1b below. So you have figure 1. Okay, this is XY plane. We have another XY axis. This is the X axis, so this is Y axis, and this is X axis. So this is 0, 0. Okay. Then we have some coordinates, and these coordinates are going to -3, going to 2. So you have to draw it well. Let me stretch it. So this is a certain straight line. So the first point, which is P, let me look. This is R, point R. It is 2, it is 1, 2. So this is 1, this is 2. So 1, 2. And then we have point Q. And this is point Q. Okay. Point Q, it is -2, comma R. -2, 0. And then you've got again another point here. This is point P now. So this is -3, -2. Okay. So this is figure 1D. Okay. So question asks us to find gradients of PQ, pair of planes, and hence we have to compare and comment that what we see. Solution. Very simple question. I'm about to finish this session. Okay, solution. So the first step, I say that you have to recall the formula that slope is equal to change in y over change in x. You can use y1 minus y2 over x1 minus x2. So then we say that the gradient of PQ, gradients of segment PQ, suppose this is x2, y2, x1, y1, right? So y2, which is 0 minus what? 0 minus -2. And hence x2, which is -2 minus what? -3. So this is negative times negative is equal to positive. So this will make 0 plus +2. I want you to understand negative times negative is positive. So this will make negative 2 plus 3. So 0 plus 2, this is equal to 2. 3 plus minus 2, this is equal to 1. 2 over 1 is equal to what? Is equal to 2. Again, the slope of, I guess you're being asked the slope of QR, the slope of point QR. Take the coordinates of QR, we find by taking change in y over change in x, which is equal to y2 minus y1 and x2 minus x1, and take the coordinates of r to be x2, y2. So y2 is equal to 2 minus x2, or y1 it is 0, divided by x2 it is 1, so 1 minus negative 2. So then we say that slope of point QR, this is equal to what? Is equal to 2 in numerator. Negative is negative is equal to positive, so 1 plus 2 is equal to 3, right? So it means 230. So 230, and that is a 3. Okay? So what happened? So 1, 2, negative 2, 0. Yeah. So because I was trying to think about these points. So for you to understand that this concept, it means that we should eliminate these points. It means that in 1, 2. Okay. So I think that to sweep up this concept, we have negative 2, 0, and then because I made some few changes, okay? I made some few changes, so negative 2, 0, and then 1, 2. I want to change that question. 1, 2. This is Q, and this is R, and then with P. Negative 3, negative 2. So let me change this question. So forget about what I've said by using these points. Okay? These points. So this point. So what point? So it means point P, it is what? Negative 3, negative 2. These points are not on the straight. They are not on the same straight line. So they are on different lines. So R is negative 3, that one's, and then point Q, it is what? Negative 2, 0. Right? So compare by using these points. So then compare gradients. The gradients were using these points. And another point that I was very impressed in commenting, if PQR, if points P, Q, and D are collinear, right? Collinear. So we found the slope for PQ and slope for QR. Slope for PQ is 2. Slope of QR is 2 over 3. All the points should lie on the same straight line. We can realize this when we sketch, we draw that actual planes. The slope of NAP of the collinear planes is always the same. So for this case, you say that the slope of PQ is not equal to the slope of QR. So because it's not equal to that, so therefore we say that P, Q, and D are not collinear planes. So this is the final response. Excuse me for formulating badly that example 4. But you have understood. So let me leave now the homework. So this is homework 2. You have to make sure that you do it. Homework 2 for session 2. And the question says that show that the following points are either collinear or not. So these are the points. Point A, it is -3, -2. You may use sketching, you may use the concept of finding Bayer gradients. Point B is -1, 0. And point C, these are not required. And point C, it is 1, 2. So submit your homework on the comment section of this video. Okay, that's the end of our session 2 of coordinate geometry, which is titled Gradients of the Straight Line. I thank God who have been with me since the preparations of this session, and I thank God who have given me power, strength, understanding, intelligence to teach you. And also I thank you for taking your time to follow along. And I believe you have a number of questions to ask me. Ask me in the comment sections. I will try my level best to answer your question. Remember that Olenjolai does not know everything, but I know small portions of coordinate geometry. So make sure that you subscribe, because we'll be having more than 300, more than 400, videos in this YouTube channel. So that make sure that you subscribe so you'll get the official notification. So I'd like to invite you in the next sessions when I'll be teaching you the second concept, which is called the equation of the straight line. So join me, we'll be doing different questions in order to understand that concept, and join me even in other sessions, and make sure that you share these contents with your colleagues. And I would like to bless you, and may God bless you abundantly. In case that also you want to offer your free willing Thanksgiving, you may use this this phone number to send your free willings in order to participate in the running cost for this program. So may real God bless you and keep you safe until we meet again in the session 3. May God bless you.